Chapter 5, Lesson 2, this is day 1. We're going to talk about dividing polynomials. So today we're going to take a look at long division, and then tomorrow we'll take a look at synthetic division. So there's a couple different things when we're dividing polynomials. So a little bit of review here. We can just have where we're simplifying. Okay, so we have this monomial divided by a monomial here in letter A. So we have 10x to the 5th y to the 7th over 2xy. So again, if you want to, you can always split this up into multiple fractions. So I can take my numbers, 10 divided by 2, my x's, x to the 5th over x, and my y's, y to the 7th over y, and simplify each part. Well, 10 divided by 2 is 5, x to the 5th over x. Remember, subtracting those exponents, 5 minus 1 is 4, so x to the 4th, and then 7 y to the 7th over y, again that's 1, so 7 minus 1 is 6, so y to the 6th, and there's my answer. Now again, you don't have to separate each to separate fractions, but that's the idea. I'm looking at my numbers, I'm looking at my x's and simplifying, I'm looking at my y's and simplifying, or whatever variables I have. So take a look at letter B. We have negative 18 a b to the 4th c to the 5th over 9b squared c to the 3rd. So again, looking at my numbers, negative 18 divided by 9. 18 divided by 9 is 2, so we have a negative 2. Looking at my a's, well, I only have an a on top, no a's on the bottom, so I'm just going to rewrite my a. Nothing changes. Looking at my b's now, I have b to the 4th over b squared. So 4 minus 2 is 2, so b squared. And then c to the 5th over c to the 3rd. 5 minus 3 again is 2, so c squared, so negative 2ab squared c squared. So they were just simplifying those exponents just like we did in a previous lesson. So now let's take a look here. Same ideas when we're dividing a polynomial here by a monomial. The only difference is I'm going to do this multiple times. So in looking at example 1, we have polynomial here divided by a monomial. So on top we had a polynomial 20 c to the 4th d to the 3rd f minus 16 cf or cdf squared plus 4 cdf, and it's all divided by 4 cdf. Now this 4 cdf is going to get divided by every single term. So it's like I have 3 different problems. So here's a term, so there's my 3 terms. This 4 CDF gets divided by each term. So I'm going to do this division 4 times, just like I did in the previous problem. I'm going to do it 4 times though. So 20 divided by 4 is 5. C to the 4th divided by c, or 4 minus 1 is just c to the 3rd. d to the 3rd divided by d, 3 minus 1 is d squared. And f divided by f is just 1, and I don't have to rewrite it. In the second term now, 16 divided by 4 is 4, so a negative 4. c divided by c is 1, d divided by d is 1, f squared divided by f, 2 minus 1 is just 1f. And my last term then, 4 divided by 4 is 1, c divided by c is 1, d divided by d is 1, and f divided by f is 1, so just a 1 there as a placeholder. So however many terms I have in the top, that's how many terms I'm going to have in that bottom when I'm divided by that monomial. So 3 terms in the top, divided by a monomial, 3 terms in my answer. So same thing here, let's take a look at letter B. Again, if you want to rewrite it, you can. You don't necessarily have to rewrite it. If you just remember, each term gets divided by 5ab. So 5 divided by 5 is 1. A squared divided by a, 2 minus 1 is just a. B divided by b is 1. So just an a in that first term. Second term, negative 15 divided by 5 is a negative 3. Get rid of the plus sign, so negative 3. A divided by a is 1. B to the 3rd over b, 3 minus 1 is b squared. And then the last term there, 10 divided by 5 is 2. A to the 3rd divided by a, 3 minus 1 is a squared. and b to the fourth minus, or divided by b, so 4 minus 1 is b to the third. And there's my 3 terms. Alright, so here's where it's going to get a little different. Again, it's division you have done before. We're going to do long division. So just like in elementary school, when you learn long division, that's what we're going to do. So how do we do this? 250 divided by 6. Well, 6 is on the outside with our little division bracket. 250 inside. And now we're going to divide. So 6 can't go into 2. So now I'm going to look at 25. So 6 going into 25. How many times does 6 go into 25? Well, 4 times. 4 times 6 is 24. And then, just like before, we subtract these values. So 25 minus 24 gives me 1. Bring down the next number. So now I have a 10. So 6 now into 10 goes 1 time. 1 times 6 is 6. And then again we subtract. 10 minus 6, 4. And so we have this remainder. So a lot of times before it used to be like, oh, I'll just put this little R4 here, remainder 4, 41 remainder 4. Well, yes, you did do that, but we're not going to do that. What we're going to do here, we have a positive 4, so I'm going to put plus, and then I'm going to put a fraction, 4 over whatever I'm dividing by. In this case, it was 6. So 4 over 6, and again, you could reduce that. You could simplify that down if you want to make it a little bit more specific into 2/3, 41 and 2/3, okay? But for the sake of this, that's the idea, okay? So again, let's do our long division here. 8,640 divided by 15, so we have 15 again on the outside. Inside my division bracket, 8640. And again, 15 can't go into 8, so what about 15 into 86? And that's going to go around 5 times. So 5 times 5 is 25. Carry the 2. 5 times 1 is 5. Plus 2 is 75. So we subtract now. It's 86 minus 75. And that gives me 11. 15 can't go into 11, which is good. So we're going to bring down this 4. So now I have 15 into 114. And that's going to go 7 times. So 7 times 15 gives me 105. So again, we're subtracting. So 114 minus 105, that leaves me with a 9. Again, bring down the next number, that's a 0. So 15 into 90, and that goes 6 times. 6 times 15 is 90. And again, we're subtracting, and that leaves me with no remainder. So an actual factor here, 15 is a factor of 8,640. It goes in evenly 576 times. Alright, so that's the idea. That's what we're going to look at here when we're dividing with polynomials here now. So we're going to use long division. So again, what I'm dividing by is x minus 3. That goes on the outside. What goes inside my bracket? X squared plus 7x minus 30. Now, when we're doing this, we're really looking at this front term. And then the first time I'm looking at, and I'm eliminating the first number in what I have, okay? So x into x squared. How many times does x go into x squared? So x goes into x squared one more time. So I need one more x. So x times x is x squared. Negative 3 times x is negative 3x. So again, just like before, we're multiplying that. But I have to distribute that x into both the x and the minus 3. So each time I put something up above, I'm going to have 2 terms down below to subtract. So again, we're subtracting. So minus and the negative becomes a positive now. So x squared minus x, this cancels. 7x plus 3x gives me a 10x. Bring down the next term, so minus 30. Again, I'm looking, what do I need to get the x by to get 10x? So what times x gives me 10x? Well, 10. So I'm going to add 10 here. So 10 times x is a positive 10x. 10 times negative 3 is a negative 30. Again, we're subtracting, so minus negative becomes positive. So So 10x minus 10x, 0. Negative 30 plus 30 gives me 0. No remainder. And there's my answer, x plus 10. So again, there's my two factors of x squared plus 7x minus 30. X plus x minus 3 and x plus 10. I want you to take a minute, solve the next one here. So let's get this set up. So x minus 5 again out front, inside my division bracket, x squared minus 2x minus 15. Again, eliminate that first term as you move through here and see what you get. So hopefully you got x plus 3 as your answer. So you can see here, x goes into x squared x times, so x times x gives me x squared, so that's what I multiplied by. X times negative 5 is the negative 5x, and then again we subtract, so that turns that negative 5x into a positive, so we combine those then. X squareds cancel, negative 2x plus 5x gives me 3x, bring down the negative 15. So what gives me 3? What do I need to multiply x by to get 3x? Well, I need to multiply it by 3. So 3 times x is 3x. 3 times negative 5 is negative 15. Again, subtract, so the negative becomes positive then. And both the 3x and the 15 cancel out, so there's no remainder, just x plus 3 for my division. Okay, so we can divide polynomials by binomials, get no remainder. But what happens if we do get a remainder? So let's take a look here at the next example. So here we're going to end up with a remainder. So again, same setup, x plus 2 is out front, being divided x squared minus 6x minus 20. So again, eliminate that first term. Everything's exactly the same. What times x gives me x squared? Well, x does. X times x, x squared. X times 2, 2x. Subtract. So again, I leave it open. If it's positive, I don't write anything, and then I put my subtraction signs in there. That's going to be the biggest mistake. So x squared minus x squared is 0. Negative 6x minus 2x is negative 8x. Bring down the next term is negative 20. So what times x gives me negative 8x? Negative 8. So negative 8 times x, negative 8x. Negative 8 times a positive 2 is a negative 16. So again, subtract. So now they both become positives. So negative 8x plus 8x is 0. Negative 20 plus 16 gives me a negative 4. So again, just like we did before, this sign is going to go up top. 4 is my remainder, and it's being divided by x plus 2 on the bottom. So there is my final answer. X minus 8 minus 4 over x plus 2. So everything comes out the same. The only difference is, instead of a 0 at the very bottom, at the end of our equation, we're going to get a number, and that number just goes into a fraction with what we're dividing by. So let's try one more time here. So we have x plus 1 on the outside, 2x squared plus 4x minus 8. So again, what do I need to multiply x by to get a 2x squared? So I need to multiply by a 2 and an x. So 2x times x, 2x squared. 2x times 1 is just 2x. So then we subtract. So 2x minus 2x is 0. 4x minus 2x is 2x. Minus 8 comes down. And again, what do we need to multiply x by to get 2x? Is just a 2. So 2 times x is 2x. 2 times 1 is 2. Again, subtract. So 2x minus 2x is 0. Negative 8 minus 2 is a negative 10. And so then we have a minus 10 over x plus 1 in that fraction. So 2x plus 2 minus 10 over x plus 1. All right, we got one more example here, so let's take a look here. So again, how would you rewrite this? What about a negative exponent? So this negative, what's a negative exponent do? Well, again, a negative exponent sends things to the bottom, changes where it's at in the fraction, right? So what has the negative exponent? This has the negative exponent, so this whole thing is going to move down to that bottom. So what it looks like is I have x to the fourth minus 3x to the third plus 2x squared minus 4x plus 4 all over this parentheses x minus 1. I don't really need the parentheses anymore because I have the fraction bar. So again, division, fraction is just division. So what are we doing here? We're dividing this top by x minus 1. So now we can do this long division to solve. So we have x minus 1 out front. Inside we have x to the fourth minus 3x to the third plus 2x squared minus 4x plus 4. And again, now we can do our multiplication. So what do I need to multiply x by to get x to the fourth? Well, I need 3 more x's. So x to the third times x is x to the fourth. X to the third times negative 1 is negative 1x to the third. So subtract, so that becomes positive. So these cancel. Negative 3x plus 1 is a negative 2x to the third. Bring down the next term, so 2x squared. X going into negative 2x to the third. Well, I need a negative 2, and I need 2 more x's. So negative 2x squared times x is negative 2x to the third. And negative 2x squared times negative 1 is a positive 2x squared. So minus, again, this first term, 2x to the third, cancels out. And the 2x squared minus 2x gives me a 0 as well. So that's okay. I just still bring down my next term, minus 4x, right? And when that happens, a lot of times you're going to bring down both terms. So I'm going to bring down the plus 4 as well. So I have a 0. I don't really need to put anything up top. Okay? A lot of times in our older division we put a 0 in there as a placeholder. We don't need to put anything in there. But what I'm going to do now is looking at x into negative 4x. So I just need a negative 4. So negative 4 times x is negative 4x. Negative 4 times a negative 1 is a positive 4. And again, we do our subtraction, that becomes positive and a negative, and we end up with 0 remainder. So here's my answer, x to the third minus 2x squared minus 4. And you can see, because that 0 in there, we skipped that x. Okay, so this 0 in here, we end up skipping an x and go straight to the constant number of negative 4. Okay, so that's all that happens with that 0. Alright, so that's the basic notes. There's some extra problems down below you can take a look at. I would encourage you to take a look at number 4. Okay, so I would encourage you to take a look at number 4 and doing those problems there. So you can try those. I'll put the answers up there and you can check your answers there with what I have. Again, check number 4. It's a little different at times. Kind of like our example that we just did. So as you can see, 1, 2, and 3 answers are here. All the work is there. You check your answers with what you have. I'm going to talk you through number 4 here. Again, the setup's exactly the same. What you notice though is we have an exponent of 3, exponent of 2, but here we're missing the exponent of just the x. So it's not here. It's okay. You don't have to write it in there, but again, it's going to show up here eventually. And you'll see here what I mean when we get there. So again, we're doing this the same way. X into x to the third. Again, that goes in x squared times. So x squared times x gives me x to the third. X squared times negative 3 gives me a negative 3x squared. Again, we subtract just like we did before. So these first x to the thirds cancel. Negative 2x squared plus 3x gives me an x squared. Again, you can bring down this next term, but we're not really going to need it yet. Okay, so again, I'm taking x into x squared. Well, I need to do that. I need 1x. So x times x is x squared. X times negative 3 is a negative 3x. You can see why this negative 4 doesn't really come down, because I can't really combine it with the x yet. Okay, so you could bring it down. no big deal. But again, I can't combine the -4 and the -3 because they're not like terms, right? So I do my subtraction here. So that becomes a positive 3x. So then I have 3x and a -4 to bring down, because both of them, they don't combine, so they just both come down. And now again, now I'm looking at x into 3x, so that goes in 3 times. So 3 times x is 3x. 3 times -3 is a -9. And then we subtract. So subtract. So 3x is canceled. -4 plus 9 gives me a positive 5. And so then this has a remainder of positive 5 over x minus 3. So you can kind of see here, this is skipping that x term, okay? We have x to the third, x squared, skipping the x term, but it does show up right down in here. So you can put it in there if you want to. You don't have to. Just remember that this -4 and the 3x cannot combine together. So you just bring them both down and do one more step to solve. Alright, see you guys.